Module 4. Experimental Design and Results Analysis. Mark Twain said, "Facts are stubborn things, but statistics are pliable." Former British Prime Minister Sir Winston Churchill said, "The only statistics you can trust are those you've falsified yourself." Statistics allow researchers the power to show and share advances in human society. In research methods, regression is a statistical technique that examines the relationship between variables. Regression allows the researcher to infer that there is a relationship between two or more variables. It helps researchers understand the strength and direction of the relationship between variables and make predictions or test hypotheses. There are several types of regression analyses commonly used in research methods. Two more common methods are simple linear regression and multiple linear regression. Simple linear regression is used when there is a single independent and a single dependent variable. It is used to find the relationship between both variables. An example for linear regression would be on the question, does self-esteem predict academic performance in high school students? Multiple linear regression is where there are multiple independent variables. This is when the researcher wants to consider the combined effects of multiple variables on the dependent variable. An example might be looking at the scores that the high school students get on their final psychology exam when looking at the hours they studied, their attendance in the class for the term, and their level of anxiety. The three variables can be compared to see what the relationship is with the final grade on the exam. A single case design is used to study the effects of an intervention or treatment on individual subjects. The single case design does not incorporate control groups, but focused on the behavior of a single participant in depth over time. These designs are particularly useful when studying rare behaviors, complex interactions, a specific class, company, or school. Since there is no control group for the researcher to compare the results to, the researcher will use a pre-treatment observation to evaluate the treatment effects. Pre-treatment observations serve as a baseline or standard for comparison to evaluate the effects of the treatment or intervention. These baseline observations are typically collected before implementing the intervention and provide a reference point for assessing any changes in the behavior of the individual participant. This baseline shows the researcher the target or natural behavior of the participant prior to any treatment. When the treatment is introduced and the post-treatment behavior is collected, the researcher can see if there has been changes because of the treatment. Specific types of single care designs include A-B design, ABA design, multiple baseline design, alternating treatments design, and withdrawal design. A-B design is the simplest single case design, where the behavior is measured during a baseline phase, A, and then during an intervention phase, B. It allows for a comparison of the behavior before and after the intervention. Reversal or ABA design adds a second baseline phase after the intervention phase. It involves measuring the behavior during a baseline phase, A, implementing the intervention, B, and then returning to the baseline phase, A, to observe if the behavior changes systematically with the introduction and removal of the intervention. The reversal provides evidence of the intervention's effectiveness. Multiple baseline design. Researchers establish baselines for multiple behaviors, individuals, or settings before implementing the intervention. The intervention is then applied sequentially across the different baselines, allowing researchers to observe the effects of the treatment on each behavior, individual, or setting. All the target behaviors should change, but only after the treatment is given for each one. Alternating treatments design involves comparing the effects of two or more treatments by alternating their application across different sessions or conditions. The aim is to determine which treatment produces the desired behavior change more effectively. Withdrawal design is like the reversal design. The withdrawal design involves implementing an intervention, B, and then withdrawing it to observe if the behavior reverts to the baseline, A. However, in the withdrawal design, the intervention is not reintroduced as in the reversal design. Quantitative research is a way to learn about a particular group of people, known as a sample population. It aims to derive objective and generalized conclusions by examining patterns, relationships, and trends within a specific population. Quantitative research relies on data that are observed or measured to examine questions about the sample population. The sample population is chosen to represent the factors like diversity, behaviors, attitudes, preferences, and characteristics of a larger population, which allows the researcher to make inferences about the larger population based on the finding from the sample. Quantitative research typically involves collecting data through surveys, experiments, or observations. This data is often numerical in nature and is analyzed using statistical methods to identify patterns, test hypotheses, and draw conclusions about the population under study. Non-experimental quantitative research is a type of research study that aims to collect and analyze numerical data to answer research questions or test hypotheses without manipulating any variables or implementing interventions. It is needed in psychology since some IVs cannot be manipulated. There are ethical and practical considerations, and it can provide evidence for predictor variables. In non-experimental quantitative research, researchers observe and measure variables as they naturally occur or collect data through surveys, questionnaires, existing databases, or other means. The primary focus is on gathering numerical data that can be subjected to statistical analysis to identify patterns, relationships, or associations. There are several types of non-experimental quantitative research designs: descriptive, correlational, cross-sectional, longitudinal, and survey. Descriptive studies aim to describe characteristics, behaviors, or phenomena in a population or specific group. Researchers collect data through surveys, observations, or existing records to summarize and present the findings. Correlational studies investigate the relationships or associations between two or more variables. Researchers collect data on the variables of interest and analyze them to determine the strength and direction of the relationship using correlation coefficients or regression analysis. In cross-sectional studies, researchers collect data at a single point in time from different individuals or groups. They aim to examine relationships or differences between variables within a specific time frame. Longitudinal studies collect data from the same individuals or groups over an extended period. They aim to track changes or patterns over time and can provide insights into causality and the effects of variables over a longer duration. Survey research uses questionnaires or surveys to gather data from a sample or population. They can collect information on opinions, attitudes, behaviors, or demographics, allowing for statistical analysis and generalization to a larger population. An example of quantitative research in psychology might look at the relationship between the amount of sleep and academic performance. The researcher could take a sample from one university or several and have the participants use a sleep tracking device or self-reports to collect data on the duration of time the participant slept. The participants would keep a daily and weekly log and share that when the study is over. The researcher could collect data on academic performance from their GPA or exam scores. Then the data would be calculated using statistical techniques, and then the finding would be assessed and conclusions drawn. Matching is a method of controlling confusion or confounding variables in a study when setting up groups to compare. Confounding variables are factors that are related to both the independent and dependent variable, which can influence the results, making it hard to determine the true effect of the independent variable. The goal then of matching is to make sure that the for is not confounded and that both the for and the dv are not affected by a third variable. Matching involves identifying participants who are similar on relevant variables and then assigning them to different groups in a way that ensures balance across those variables. By doing so, the influence of these confounding variables is minimized, and the comparison between groups becomes more valid. Depending on the research design, there are different approaches to matching. Individual matching is a method where the participants are matched individually based on specific characteristics. Group matching involves matching an entire group or cluster of participants rather than individuals. For example, participants of similar ages are matched and then assigned to different groups. Covariant matching is when participants are matched on one or more specific variables, which are known as covariates. An example of matching could be a research design looking at a new teaching method to improve academic performance in elementary school children. If the researcher is looking for variables that may impact academic performance, such as prior academic achievement, social economic status, or learning style preference, the use of matched participants can help this research design. The students would be paired based on their similar prior academic achievement scores, similar socioeconomic backgrounds, and similar learning style preferences. Participants would be randomly chosen from each pair to an experimental group, which received the new teaching method, and the other participants would make up the control group, which will receive the traditional training method. After collecting the data on academic performance and statistical analysis is completed, the data would be analyzed to see if the results lead to the new teaching methods having significant improvement in academic performance. Surveys is a widely used data collection tool to gather information about individuals, groups, or populations. It involves asking a series of questions to elicit responses from participants. Surveys are commonly used in psychology research to collect self-report data from study participants. They may focus on factual information about the individual, or it might aim to obtain the opinion of the survey taker. Surveys can provide a structured and standardized way to collect data from many participants, allowing for systematic analysis and generalization of findings to a broader population. When designing a survey, researchers follow a series of steps in conducting a survey. The planning and design of the research study is the first initial step. This involves identifying the research objectives, defining the target population, and determining the scope and purpose of the survey. The second step is the construction and refinement of the instrument, which is the survey. This step involves developing the survey instrument itself. This would include designing the questionnaire and ensuring the instrument measures what it intends to measure. The third step is collecting the data. Once the survey instrument is finalized, the data collection can begin. This may involve distributing the survey to participants through online platforms, emails, mail, or in-person interviews. The researcher will follow an ethical code to obtain informed consents and ensure confidentiality of the participants. The fourth step is to clean the data, which involves reviewing the responses, checking for completeness and accuracy, and identifying and correcting any inconsistencies or errors. The cleaning of the data may include removing outliers, resolving missing data, and ensuring data quality before proceeding to the analysis. The fifth step is interpreting the results. This final step involves analyzing the survey data and interpreting the results considering the research objectives. The findings should be presented in a clear and meaningful way. This could be in the form of tables, charts, or narratives. The research objectives and contribution to the existing knowledge in the field should also be presented. Qualitative and quantitative research are two distinct approaches used in research to gather and analyze data. Qualitative research is interpretive, involves multiple methods, and focuses on people in their natural environment. It is a process of inquiry that seeks an in-depth understanding of social phenomena within their natural setting. It focuses on the why rather than the what of social phenomena and relies on the direct experiences of human beings as meaning-making agents in their everyday lives. Qualitative research aims to understand the depth and richness of human experiences, behaviors, and social phenomena. It explores subjective meanings, interpretations, and context-specific factors. It relies on methods such as interviews, focus groups, observations, and document analysis. These methods allow researchers to gather detailed, narrative-based, and non-numerical data. Qualitative data analysis involves identifying themes, patterns, and relationships in the data. It relies on coding, categorization, and interpretation of textual or visual data to generate rich descriptions and theories. Quantitative research aims to measure, quantify, and generalize phenomena, typically focusing on objective facts, relationships, and cause and effect explanations. It emphasizes numerical data and statistical analysis. It relies on structured methods such as surveys, experiments, and structured observations. It involves collecting numerical data that can be analyzed statistically. Quantitative research produces findings that are generalizable and often presented in the form of statistical summaries, graphs, charts, or tables. It provides objective information about the prevalence, frequency, and relationships among variables. Correlation refers to a statistical relationship between two variables. It describes how changes in one variable are associated with changes in another variable. Correlation does not imply causation, meaning that a correlation between two variables does not necessarily mean that one variable causes change in the other. A coefficient is the numerical factor of a term containing constant and variables. For example, in the term 2x, 2 is the coefficient. X would be the variable. The correlation coefficient is a numerical measure that quantifies the strength and direction of the relationship between two variables. It provides a standardized value that ranges between -1 and +1. With correlation, the researcher is looking for the strength of the relationship where the absolute value of the correlation coefficient indicates the strength of the relationship between the variables. A value close to +1 or -1 indicates a strong relationship, while a value closer to 0 indicates a weak relationship. The sign of the correlation coefficient indicates the direction of the relationship. A positive correlation coefficient, +1, indicates a direct or positive relationship, meaning that as one variable increases, the other variable also tends to increase. A negative correlation coefficient, -1, indicates an inverse or negative relationship, meaning that as one variable increases, the other variable tends to decrease. The correlation coefficient provides a measure of the linear relationship between variables. A correlation coefficient of +1 indicates a perfect positive correlation, where the variables move in perfect synchronization. A correlation coefficient of -1 indicates a perfect negative correlation, where the variables move in opposite directions. A correlation coefficient of 0 indicates no linear relationship between the variables. An example of a correlation research question might ask, is there a relationship between self-esteem and life satisfaction in adolescence? The researcher could select a sample of adolescents from a school or community setting and create a survey questionnaire with items that assess participants' self-esteem and life satisfaction. The survey is administered, and the surveys are collected from the participants. A calculation of the correlation coefficient is completed to assess the strength and direction of the relationship between self-esteem and life satisfaction. The three possible directions with correlational coefficient are that a positive and significant result suggests that higher levels of self-esteem are associated with higher levels of life satisfaction. Conversely, if the correlation coefficient is negative and significant, it indicates that lower levels of self-esteem are associated with lower levels of life satisfaction. A correlation coefficient close to 0 suggests a weak or non-existent relationship between the two variables.